Research and innovation in Futuris.
In this harsh, isolated, semi-desert region north of Cairo in Egypt is 150 acres of beans, peas and orange trees. But there's a problem. An endless need for water.
Each plant needs a certain amount of water depending on the season. Peas, for instance, need a lot of water. I have to irrigate them at least 5 hours a day. Oranges and grapes need less water during the winter. But in any case, I never need less than 4,000 cubic meters per day.
They rely on old diesel pumps to bring the water to the surface. But local scientists have come up with a different solution to answer a variety of problems.
In Egypt, these diesel pumps are widespread, and we want this to change. These diesel machines have many inherent problems. They are very noisy and very polluting. They release lots of toxic gases into the atmosphere. They're also quite expensive to use and maintain. You need to buy diesel, pass technical controls, change the motor oil and buy spare parts. All this comes at a huge cost.
So how can water be pumped to the surface in a green, cheap way? Researchers are looking at the sun for answers.
We are going to an experimental station where we are testing the use of renewable energies to pump water and to provide irrigation in semi-desert regions.
The experimental station is well off the beaten track. And these are not ordinary photovoltaic panels. They use a brand new generation of photovoltaic cells built in Germany as part of a European Union research project.
Our system, concentrated photovoltaic technologies, consists of a panel of lenses, in which 200 little single lenses concentrate the sun's rays on these very little solar cells. They're really minuscule. This front section only focuses the light. If we look at the rear section, we see these little squares. They are heat reducers which absorb the heat. The photovoltaic solar cells are inside these squares. Each cell is only 2 millimeters in diameter.
The trackers follow the sun all day. They're thought to be far more efficient than ordinary photovoltaic panels.
With our technology, we concentrate the light on these tiny but very efficient solar cells. The main advantage is that one concentrated photovoltaic cell is up to twice as efficient as a classic solar cell.
In ideal conditions, each tracker produces around 50 kilowatts of electricity per hour. These Spanish researchers are measuring the efficiency of the trackers in varying weather conditions.
The clearer the sky, the more radiation and the more energy these panels can generate. Temperature works the other way round. The hotter it is, the less energy the trackers will make, but temperature is not a big factor. Wind is more important. A slight wind will increase energy production because it will lower the heat on the surface of the mirrors, cooling the whole system and making it more efficient. But strong winds can interfere with the tracker's movement. Strong wind can also leave dirt on the mirror, which can significantly reduce energy production.
Energy is transformed and stored in this small building using a complex system set up by German electrical engineers.
We receive alternating current from the panels, which arrives here and is fed into the AC main power grid. These three inverters establish an electrical grid, and when there hasn't been any sun for a few days, they also supply power to the panels so they can rotate towards the sun. In here is the DC control box, which measures the power and stores it in the battery. So here are the batteries. The reservoir is small, just enough to power the captors for 2 days, so that they can follow the sun even when it's cloudy.
Electricity is then used to pump water up from a depth of almost 40 meters, desalinate it, and then irrigate nearby experimental wheat fields, supervised by local researchers.
We're going to invite farmers from the region to come and see these experimental crops. This wheat field will teach them more than 1,000 speeches and conferences about the benefits of renewable energy. People will see with their own eyes and learn how to take advantage of concentrated photovoltaic energy. And we're going to help them understand those advantages. When we get all the data, we'll translate it into figures so people will know how much they need to invest. In this easy way, they will learn how useful this technology can be in their daily lives.
And scientists say that these farmers will not be the only winners. Similar stations could be developed in other isolated semi-desert regions.
We will only have to import the concentrated photovoltaic cells from outside Egypt. All the other materials used in this experimental plant are conventional. Glass, mirrors, metals, iron. All these materials can easily be obtained locally. So we're creating jobs. This system will not only improve farmers' living conditions, but hopefully improve conditions for everyone living in isolated regions.
Scientists hope that this could soon become a reality not only in Egypt, but also in other countries which have inefficient electricity generation and supply systems. And also lots of sunlight.